Alright, next question is about the variables y and theta satisfy the following differential equation. It is given that y is equals to 0 whenever your theta is pi by 4. You have to solve that differential equation for the value of tan theta whenever your y is equals to 1. The first thing that you have to keep in your mind is that you have to introduce some constant of integration. C part means some constant that seems to be c. Why? Because that question is finding the integral after doing the implementation of y is equals to 0 and theta is equals to pi by 4. That thing should be considered, because the biggest mistake student ever do is that they are not involving some constant c. So you have to make a stereo in your mind. If limits are given to you, you must have to involve some constant of integration. If you are not introducing, then alternatively you are unable to find the answer. So अगर limits given होंगी, आपने constant of integration involve कराना है, and then you are able to get the value of c by using these points in that integration. Otherwise you are unable to get the value of c. So that is the first point that you have to keep in mind. Second point, this is dy by d theta, and y and theta are mixed one, that is y and that is theta. You have to solve that equation by using the method of separation of variable. You have to shift y terms on one side of equation and theta terms on other side of equation. That is the first point that you have to keep in mind. So first of all, write down 1 plus y, 1 plus cos 2 theta dy by d theta, which is equals to e raised to the power 3 of y. If I want to separate out my equations in way of separation of variable, so that becomes 1 plus cos of 2 theta over d theta just like 1 plus y times by 1 plus cos of 2 theta dy by d theta, which is equals to e raised to the power 3 of y. That is the form I have. So I'm wanted to get y terms to the left hand side and theta terms to the right hand side. So see what happens. I have 1 plus cos of 2 theta over d theta, which is equals to e raised to the power 3y by 1 plus y times by dy. Now dy and d theta should never be in numerator. जिसकी रिस्पेक्ट से आपने इंटीग्रेट करना है वो डिनोमिनेटर में नहीं हो सकता. So it means that you have to reverse that equation. Take a reciprocal. Once you are taking the reciprocal, you have 1 plus, that 1 plus cos 2 theta would be shifted on the denominator, that is d of theta. Taking the reciprocal, you have d theta over 1 plus cos of 2 theta, which is equals to 1 plus y to the power of negative 1, or just maintain as it is, we will do in the next step. 1 plus y e raised to the power of 3y dy. You take the reciprocal, nothing else. So 1 plus y is shifted as a numerator and e raised to the power 3y is shifted on to the denominator. Now you have to think about the integration step, how you can. If I'm considering that side only first, look here, this is 1 plus cos 2 theta. 1 plus cos 2 theta could be written by the double angle formula, that is 1 plus cos of 2 theta. You have to think a formula of cos 2 theta that will make your simplification easy. There are many formulas that you can use, double angle formula, triple angle formula. Either cos 2 theta could be written as 1 minus sine square of 2 theta by 2, 1 plus sine 2 theta by 4. There are a lot of formulas, but you have to think about a formula that makes your simplification easy, not complicated. So अगर आप cos 2 theta को sin 2 theta की फॉर्म में ले भी जाओ, sin से cos की फॉर्म में चले जाओ, तो भी आपकी इंटेग्रल में ट्राइगोनोमेट्रिक फंक्शन रिटेन करेगा. that will make your integration complex, so you can't use that. You have to think of a formula that makes your simplification easy. So for example, I am choosing my formula just like 1 plus cos 2 theta, and I want to open cos 2 theta formula in a way that make my simplification easy. I have one of a formula of cos 2 theta, that is 2 cos square of theta minus 1. That could be written as cos of 2 theta. If I apply that formula over here, that make my simplification easy. So let's do. If I'm applying it, I'm just solving that side first. 1 plus cos of 2 theta. I will solve that side later because by parts will be applicable. So 1 over 1 plus cos 2 theta d theta. I'm going to write in a way d theta over 1 plus 2 cos square of theta minus 1. That is the formula that I mentioned over here, 2 cos square of theta minus 1. So I just apply. Once I solve it, I have that negative 1 and that positive 1 will cancel each other, and my integration retaining into d theta by 2 cos square of theta. Now I can write in a way 1 by 2 could be taken outside, and 1 by cos square of theta d theta. 1 by cos square of theta could be written as 1 by 2 secant square of theta. Is it? So 1 by cos is secant, so 1 by cos square would be written as 1 by secant square theta, obvious. And integral of secant square theta is always equals to tan of theta. So at the place of secant square of theta, I am able to write 1 by 2 tan of theta. So 1 by 2 tan of theta will be the answer for that part. Left hand side I meant. Now I have to solve the right hand side. If I'm considering the right hand side, so the right hand side will become e raised to the power minus 3y times by 1 plus y times by dy. Now the key point that you have to keep in mind, partial fraction or by parts would be used over here because you don't have any choice other than by parts. By parts will be used in order to solve that part, right hand side of that integration. So you will write your answer in a way, your integration in a way. I'm doing that part with a pink marker. So that becomes e raised to the power minus 3y plus y times e raised to the power of minus 3y as a whole dy. Right? Now I am applying integration over each of the terms separately. For the first time I am writing e raised to the power minus 3y dy plus y times e raised to the power minus 3y dy. You know that exponential function integral is always written as e raised to the power minus 3y whole dividing by the power of exponential function, that is minus 3 in this case. So e raised to the power minus 3y whole dividing by minus 3 is the integral of that function. Okay, next plus y times e raised to the power minus 3y. By parts integration will be used here. If I am choosing my first function as y, for example, that is my first function marked as 1, first function. That is my second function. So by parts rule suggests that first function retain as it is integral of second one. Second function integral and first function second function derivative and first function integral in this way. So let me do here in the separate page. Like here, I am writing y times e raised to the power minus 3y dy. I just choose that my first function is y and second function is e raised to the power minus 3y. So I am choosing my first function as y. So I have at the last first function retain as it is, that one. First function retain as it is, integral of second function, integral of e raised to the power minus 3y, which becomes e raised to the power minus 3y by minus 3, minus, because of a formula, integral of first function derivation, that is 1, integral of second one, that is e raised to the power minus 3y by minus 3 dy, that becomes minus y times e raised to the power minus 3y by 3, minus minus become plus e raised to the power minus 3y by 3 dy, and minus y by 3 e raised to the power minus 3y plus 1 by 3 could be taken as outside, e raised to the power minus 3y dy, and 1 by 3 y e raised to the power minus 3y plus 1 by 3 retain as it is. Integral of e raised to the power minus 3y again becomes e raised to the power minus 3y by minus of 3 plus some constant of integration. Why I introduced that constant of integration? Because at the start of that solution for that question I suggest values of x and y are given to you, so it's necessary for you that you have to retain the value of c so that you can calculate at the end, right? So you are able to get the value of c now. Let me write in a specific form at the end, that becomes minus y e raised to the power minus 3y by 3 minus 1 by 9 e raised to the power minus 3y plus some constant of integration c. That is the answer for the partial fraction or by parts for the other function, that is y times e raised to the power minus of y. Let me crop it. Yes, that will be the answer for that one. Now I have to make a group of similar terms together. That would be 1 by 9 e raised to the power minus 3y, and other one is y e raised to the power minus 3y by minus of 3. Now I have to plug back each of the term in back to the equation, and at the end I have, now I'm writing right hand side and left hand side together. I'm combining these things because there is equality sign now. So that becomes 1 half tangent of theta, which is equals to e raised to the power negative of 3y by 3 negative 1 plus, that is negative, so that become negative y times e raised to the power minus 3y by 3 negative e raised to the power minus 3y over 9 plus some constant of integration that I marked as c. Now I have to calculate the value of c. So once my theta is equals to, if I calculate the value of theta, can I do the simplification first? That make my steps easy. Yeah, I can do the simplification first so that I can get the value in easy way. So I can make a group of these terms together, or also I can take the LCM. So I can do 1 by 2 tangent of theta, which is equals to minus 4 by 9 e raised to the power minus 3 of y minus y times e raised to the power minus 3y by 3. I did nothing, just only make a group of these terms together and solve it. And then at the end I have 1 by 2 tangent of theta minus 4 by 9 e raised to the power minus 3y minus y e raised to the power minus 3y by 3 plus some constant of integration. Now I can use the values of theta to get the final answer. So if I'm writing the value of theta as pi by 4 whenever my y value seems to be 0, that is the thing that I know already in the question. So that becomes 1 by 2 tangent of pi by 4, which is equals to minus 4 by 9 e raised to the power 0 minus 0 times by e raised to the power 0 by 3 plus some constant of integration, that is 0, or that is c I meant. And after doing the simplification I have 1 by 2 tangent of pi by 4, which is equals to minus 4 by 9 e raised to the power 0 is 1 minus 0 plus some constant of integration, that is c. Tangent pi by 4 seems to be 1. You can calculate on your calculator. So it becomes 1 by 2 times pi 1. Tangent of pi by 4 is 1, which is equals to minus 4 by 9 plus c. Now you can calculate the value of c as 1 by 2 plus 4 by 9. 1 by 2 plus 4 by 9 will become c is equals to 1 by 2. 1 by 2 plus 4 by 9, so that could be written as 17 by 18. So the value of c seems to be 17 by 18. Just go back to the main equation and put back the value of c. What was the main equation? The main equation was that one, just like marked as equation number 1. So your final answer reducing into 1 by 2 tangent of theta 1 by 2 tangent of theta, which is equals to minus 4 by 9 e raised to the power minus 3y minus y times by e raised to the power minus 3 by 3 y times e raised to the power minus 3y by 3 plus the value of c, that is 17 by 18. That will be the final answer. That is the final answer up to this point. Now you have to restrict that y is equals to 1. After finding the value of c, you have to put y is equals to 1 in the last form. So that is the equation, and just everywhere that contain y you have to put back 1. Here, here and here. So that becomes 1 by 2 tangent of theta, which is equals to minus 4 by 9 e raised to the power minus 3 minus 1 times e raised to the power minus 3 by 3 plus 17 by 18. And that become 1 by 2 tangent of theta, which is equals to minus 4 by 9 e cube minus 1 by 3 e cube plus 17 by 18. You have to express in terms of theta, tan theta. So just multiply 2 onto the other side. That become tan theta, which is equals to minus, that would become minus 4 by 9 e cube and minus 1 by 3. Once you are taking the LCM at the end, you have minus 14 by 9 e to the power of minus 3 minus, positive 17 by 18, and theta will become tan inverse of 17 by 18 minus 14 by 9 e to the power of minus 3. That will be the final answer at the end.